Hello students, welcome back to my channel. Let us continue learning chapter 11, that is pointers. Today we will be discussing the pointer arithmetics, pointers and arrays of pointers, and also about strings, how pointers are related to strings and how we can use pointers as a function parameter. Briefly we are going to understand today. So let us start. First thing is pointer arithmetic. Now what are the different operations or arithmetic operations I can perform using the pointers? So as you can see here, these are the different operator which can be used in using the pointers. That is, plus plus is nothing but your increment operator, minus minus is nothing but your decrement, plus and dot operator. These are the operators which can be used when it comes to pointers, right? Now what are the different operations that I can perform? So first thing is we can add an integer value to a pointer. Now we all know that what is a pointer? A pointer is nothing but a variable which holds the address of another variable, isn't it? So now whenever I have an address, it is nothing but it will be some number value, so I can add integer value. Okay, so for example, if I am pointing at the address 203, then adding some value, for example, if I'm adding 4 to this, then it will be 207, which is nothing but I will be pointing at the next byte of the memory, right? So we can add integer value. This is not in all the cases. Okay, we can subtract an integer value. Similarly, the way we can add, we can subtract as well. We can compare two pointers if they point the element of the same array. So comparison is possible only provided they are pointing at the same array. We all know that array is nothing but we are allocating a consecutive memory location, isn't it? So if there is a pointer which is pointing here, for example pointer 1, and if I have a pointer which is pointing over here, pointer 2, in this case only I can compare them. Okay, the comparison between these two is possible since they are pointing at the same array. If they are pointing at a different set of array, for example, if there is another pointer 3 which is pointing at a different array, the comparison is not possible. Why this is because the number of the value of the address will be same when it comes to if they are pointing at the same array. If at all I am trying to compare it with another set of value, that is another set of array, then the value might not be same, isn't it? Because we don't know where the at which part of the memory that particular array is going to get allocated. So that is the reason they should be pointing at the element of the same array if at all you want to compare them. We can subtract one pointer from another. Again, they should be pointing at the same array. Only then we can subtract each other, and we can assign one pointer to another pointer provided they both are of same type. That is, if at all you are pointing, there is a int pointer. Okay, if there is a int pointer and if there is a float pointer, then in that case I cannot assign. Okay, so for example, if at all ptr, then I cannot assign these two values. If they are both of the same type, then the assignment is possible. So we can add an integer value, we can subtract integer value from the pointer, we can compare and subtract provided they are pointing at the same array, and we can assign one value to another provided they are of the same type. I hope this is clear. So this is about your arithmetic operations or the different pointer arithmetic that we perform on pointers. So now we know that what are the operations we can perform. Let us go ahead and see which are the operations cannot be performed. Addition of two pointers. Now this is very clear that this is not possible only if they are not pointing at the same array. Subtraction of one pointer from another pointer when they do not point to the same array. So this condition, this particular condition applies over here as well. That the addition of two pointers is not possible when they are not pointing at the same array. Multiplication of pointers, again it is not possible because when you multiply certain value, that gives us a bigger value, isn't it? It might be exiting the current address value whichever is of the memory, isn't it? So multiplication or division, these are just not possible even if they are pointing at the same array. Irrespective of that, these two operations cannot be performed on array, and these two cannot be performed if they are not pointing at the same array. So these are the four operations which cannot be performed on the pointers, right? Now let us move on to the next topic, that is array of pointers. Now we have seen how do I declare a pointer for an array. Now how do I create an array of pointer? So what do you mean by pointer which is pointing at an array? Suppose I have an array A, I am declaring a pointer which is pointing at the first address of the array. This we have seen already. Now what do you understand by array of pointers? Now array of pointer is nothing but I have an array. Now each element of them is a pointer value. So when I say that, this is nothing but array of pointers. I hope you are understanding. So I am having an array which is holding all the elements of that array are pointers. So how am I going to declare it? So see here, we know that to declare a pointer we use this syntax, that is int star and the name of the variable. So when I include an array, that is square bracket with the value, this becomes array of pointer. This simply means that this particular IPTR array, which can have 5 elements, is holding. The star indicates that is nothing but array of pointers. Okay, so see this example. I'm declaring the normal variables I, J, K, L and M and giving them values. Now I am putting each of this value, that is when I say I, our memory is going to get allocated I, J, K, L, M, isn't it? So the values what I am going to store here is 10. So this is I, J is 20, K is 30, L is 40 and M is 50. So that is this line. Now next what am I doing? I am saying I pointer of 0 is equal to ampersand I. Okay. So what does that mean? So when I declared the very first statement, I said that int star I pointer, that is this line. When I declared, I am going to be initializing or declaring a array which is having pointer variables. Now each pointer variable, we know that array has subscript, isn't it? We access the elements of array using the subscript. Now when I say I pointer of 0 is nothing but this particular area, 0th place, what am I storing here? Ampersand I, that is nothing but the address of I. Suppose for example, I will take it as 200, 204, 208, 212, 260. Okay, so it need not be consecutive, continuous, but for example I am taking, so what am I saying? I pointer of 0 is equal to ampersand I, which is nothing but I am going to store the value 200 here. Okay, now star I pointer of 0 is equals to 10. So when I say star I pointer of 0 is nothing but star I pointer of 0, the whatever the content is there, that is nothing but 10. Okay, that is what I mean. So if you see this entire code here, what am I going to do? I am going to store the value of these each variable here. So that is nothing but I am going to say 204, 208, 2012, 216. So what I am doing here, first I am declaring a array of pointers, then using these code I am populating that particular array with the address of the variable which also I have declared simultaneously in this code. Okay, so I hope this is clear. So when I say array of pointers, it is nothing but a simple array which is holding each element of that pointer is nothing but the address. It is pointing at some other variable, or it is holding the address of another variable, because each of them are pointer in itself. Each element is a pointer, right? So this is all about array of pointers. Now let us see pointers and strings. So how can we have pointers and strings related? So see this example. Let us now consider a string constant hello. Now we all know that whenever we are storing a string, always we store it with /0. This is nothing but the end of the line or end of the word, okay, end of the character. S is a pointer to the memory location where H is stored. Here S can be viewed as a character array of size 6. So S I am assuming as a character array or an array of type character. Okay, suppose I am declaring it something like this. Okay, character. So S is an array of type character. I have S of 0, S of 1, S of 2, S of 3, S of 4, S of 5. Right? Now address of H, S gives the address of H. So why do we say that S gives address of H? In arrays we have learned that whenever I declare an array, if I am using only the name of the array, this is nothing but the base address. This gives me the base address. That is the very first beginning of the array, whatever the address is there. For example, if it is 1000, then S gives the very first address. So that is nothing but the base address. So what is stored in the very first location? It is nothing but H. That is why S gives the address of H. Now suppose I am having a pointer a variable A which is pointing at this particular string, that is the character, the array of characters. Then I can say that star A, what is stored in star A? Because star A is pointing at this particular array, isn't it? Again, the star A also will have the beginning address of this array, which is again nothing but 1000. That is why I say that star A gives H. Why? Because star A is nothing but a pointer which is pointing at this particular array, and star A always holds the very first address of this array. That is why again that is holding S, which is H, which is 1000, which is nothing but H. That's why when I say S also I'll get the value of H. Star A also gives the value of H. S of 0 also gives the value of H, isn't it? That is very common. S of 0 also gives the value of H. A plus plus gives the address of E. So I have a pointer variable. Now when I say A plus plus, it is nothing but I am going to move to the next element which gives me the value of E. Star A plus plus gives E. Now what is this star A plus plus? Star A plus plus is nothing but the content. Okay, when I say A, it is going to be the address. Star A, when I say it is going to be the content. Now when I am incrementing, again what is going to happen? I am going to get to the next element. This also gives the value of E. So whenever I have a string, strings are nothing but they are the array elements of set of type character. Okay, now strings are nothing but arrays of type character, and if at all I am having some pointer variable pointing at that particular array, then it always holds the base address of the string. Okay, remember this point. And also if you understand this, it becomes easier. That is only S, that is an only the, when I say the name of the array, it gives me the base address. Also when I say star A, it gives me the base address. Also S of 0, that is 0th also gives me the very first element, right? So this is all about pointers and strings. Now let us move on to the next topic, that is pointers as function parameters. So what is this function parameter? We all know that function parameter is nothing but the parameter which we pass whenever we are using a function. So for example, if I have int sum, okay, this is the function. Here what is happening? I am not using any parameter. Suppose I am using a parameter. I want to use a certain parameter. So what is going to happen? I am going to write int a. Okay, so what is this? This is nothing but a parameter. Now pointers as a function parameter means, what if I am using a pointer as a parameter of this function? So that is what pointers as a function parameter means. We know that I can send a value to a function using the parameter, but can I also use a pointer as a parameter? So see here, it works like a reference parameter to allow change to argument from within the function. So what is this reference parameter? So there are two types of parameter or two types of function call, I can say. Okay, one is call by reference, remember this. Another one is call by value. So what is the difference between them? When I say call by value is nothing but I am just passing the value. Now initially what I had here, I had written only A. So that is nothing but call by value. So whenever in the main program I am calling sum of 10, it is nothing but I am passing this value. This doesn't mean I am directly accessing the memory location. Okay. So this is called as value. But when I say call by reference, it is nothing but suppose I have declared a variable int x for which the memory has been allocated, okay, and the value is 10. And if I say sum of x and I'm using a pointer variable, or suppose I'm sending an address, then it becomes call by reference. That is, I am able to manipulate the data from the memory itself. This becomes call by reference. Now this we are going to learn in detail in the next video. For as of now you understand that pointers as a function parameters is nothing but, as you can see here, I am using a pointer variable as a parameter. I am passing pointers as a parameter, right? So let us see this program. So I am passing the pointers as to swap the value. I am taking a variable temp. Okay, I am taking a variable temp which is equal to where I am storing the content of the value x. Okay, suppose x is 10 and this is 20 and I am passing the address. So this is the address I am passing from wherever I am calling. So as you can see here, this is where the function call happens, isn't it? This is where I am calling the function, and this ampersand represent that I am passing the address. So number 1 is declared, number 2 is declared. There are some values. Let us assume that 50 and 75 is the value. Now when I am calling this function, what happens is this will pass the address. For example, if the address was 200 and 300, here I am not passing 50 and 75. Instead I am passing 200 and 300. Okay, which will come over here as the content. So star x, when I say here also I am directly accessing. So when I say int star x, I am directly accessing the memory. Star y, I am directly accessing the memory. So what am I saying here? Temp is equal to star x. So what is there in star x? Star x is nothing but the content of that element, which is nothing but 50. Next I am saying star x is equals to star y. What is the meaning of that? The content of x is equal to content of y, which is nothing but star x becomes star y is 75. Now x value becomes 75. Next I have star y is equals to temp. So what do I have in temp? 50, which is nothing but I am going to change this value to 50, and using this line I know that I have changed the value to 75. So this is how I am directly accessing the memory and I am changing the value. This is called as a reference, call by reference. I am accessing directly the memory in order to do the changes. Okay, so with this we have understood that we can also pass the pointer as a parameter. Little bit in detail we will be learning in the next video, right? So next let us see how pointers and structures are connected. Now we know that structure is nothing but a user defined data type, isn't it? I can have as many number of different types of data types in this I can add, and I can create my own type of a data type. So here in the example you can see I have a structure whose name is student, then I have roll number, okay, of type int, then I have fees of type float. Now here I am creating an object s of type student. Next I am creating a pointer variable sp which is going to hold the address of s. Now whenever I am creating s, what is going to happen? Now s is going to have roll number because it is a structure type, isn't it? And also it is going to have fees. Next, when I am saying star sp and I am storing the value, the address, suppose the address of this particular s is 1000, I am going to store 1000 over here. It is nothing but it is pointing here. Now see this carefully. I am saying star sp dot roll number is equal to 104, which is nothing but star sp dot roll number. When I say, we know that star sp means nothing but the content of the address. The content of the address 1000 dot roll number, when I say, the compiler is going to access this part, okay, and I am changing it to 104. 4. So this is how I am going to access. So instead of this roll number, usually we will use the operator called as this operator. Okay, so that is nothing but star sp roll number. When I say, what am I going to do? I am accessing the value of this particular structure, that is roll number. So I am going to also, if I want to access the fees, I will say sp fees. When I say, suppose it is 10,000, then it is nothing but I am accessing the this part. So this is how pointers and structures are connected, students. Okay, so I have a structure. Any structure I can create a pointer variable. And how am I going to do that? All you need to do is create an object of that structure, then create the pointer variable of the same type which is of the structure, and then the object address you can pass it to the structure. That is, you can save the address of this particular object in the pointer variable. Then you are able to access each element of that structure and you can change the value. Okay, and you can directly access each of the element. If there are more element also, you can use the this operator and then you can access them directly and do the changes. So this is about pointers and structures. So next let us see what are the different types of memory allocations. Okay, so memory allocations is nothing but we can have static allocation of memory and dynamic allocation of memory. Now what is the static allocation? Static is nothing but whenever you are creating it beforehand, you are writing it in the code itself. So the amount of memory to be allocated, it predicted and pre-known. Example, int a. Usually the declaration, variable declaration, whatever we do, they are called as static allocation of memory. Then what is a different kind of allocation we can use? Now that is called as a dynamic allocation of memory. So the amount of memory to be allocated is not known. You do not know beforehand that how much of memory you require. This memory is allocated during the runtime. Okay. So how is that possible? C++ supports dynamic allocation and deallocation of the objects using new and delete operator. This is important. Okay, so we can use new and delete operator in order to allocate and deallocate the memory. Now these operators allocate memory for objects from the pool called as a free store. This terminology is also important. Now there is a pool of free memories. Okay, they are all collected together, called as a free store. From there, these operator, that is new operator, picks the memory if at all it needs to be allocated, and this delete operator, what it does is it deallocates the memory and give it back to the free store. Understood? So I have something called as a free store. Whenever I need, I will use the new operator and take the memory, and whenever I do not want any memory, then I will use the delete operator and put it back in the free store. So this is how the dynamic allocation of the memory works. So see here, to allocate memory of type integer. So what is the syntax? If you want integer, so again we are using a pointer variable. You will create a pointer variable of type int and you will say new int. So new is the keyword you are using. Okay, now see here, for example, I have said int star p number is equal to new int. So this is how I am creating a new I'm creating a dynamically, I'm creating the memory. Okay, if at all you want to create an array, what you will do? I'm saying, suppose I want to create an array of type double. In that case, what am I doing? I'm saying double, I'm giving the pointer and then dptr is equal to new, whatever the type I want. Okay, as simple as that. The type will remain same in both the sides, and then I am going to give some name here and then the keyword new. Next, to allocate the dynamic structure variable, if you want to create a structure variable. Now we have seen the structure declaration in the previous example. Suppose if I am using the same type, I will say student sp is equals to, so I am creating an object of that type, then I am using the keyword new, which is of type student. Again here, student and student is nothing but they are of the same type, which is the structure. and this is the new variable I am creating, and using this keyword I will allocate the memory dynamically, right? Okay. Now I have created the memory, so how am I going to release it? So in order to release that, use delete function to free the dynamic memory as delete IPTR. So we, in the previous example, we created the IPTR. All you have to do is use the keyword delete and then the variable name which you have created. Similarly to array, you will use delete and then the name of the array. To delete the structure, you will use the keyword delete and name the type of the or the what name of the structure. So very simple, just use the keyword delete and the name of the variable whatever you have created. I hope this is clear, students. So finally, let us see the difference between static allocation of memory and dynamic allocation of memory. So we know that static is nothing but it is fixed, dynamic is nothing but during the runtime we are allocating the memory. So memory is allocated before the execution of the program begins. So we already know the what is type of a memory we require. Dynamic allocation of memory is allocated during the execution of the program. When the program is running, we are allocating the memory. No memory allocation or reallocation actions are performed during execution, but memory bindings are established and destroyed during the execution. Okay, it is not during the execution, this happens during the execution. Variables remains permanently allocated. So even after the we are going to allocate the memory, they are permanent, we cannot deallocate them, wherein which allocated only when the program unit is active, and after that it gets deallocated. This is implemented using stacks and heaps, implemented using data segments. So these are the differences you should know, students. This is important, can come for the examination. I hope this part is clear. So in today's session, we have covered a lot of small topics, from the operators to arrays of pointers to strings to the allocation and deallocation. I hope this is clear and it is helping in your preparation. So that's all in today's session, students. Thank you for watching. Keep learning.